All right, so welcome back to the sections. After that, we're gonna have the lectures until next Thursday. So we're gonna start the proof very soon. So for all the concern that you have, such as the midterm grade, so my internet connection is very slow, and there were some missing part from student who submit the exam. So this is my reminder that we should submit all the files, all the pages, scrap paper if you have them on Blackboard. So just be mindful that you need to submit everything on Blackboard so that I can grade them. Um, Out of that, I'm pretty sure that people, some of you did really well, some of you did not do really well for that part. You should have received your grade, but for some reason the system was very slow. My connection was up and down, from yesterday and today. So we have enough time. We call the service provider to get it fixed as soon as possible. And I might be disconnected for some reason, so my internet is really unstable during this time for some reason I don't know. Um, so for the time being, I also have some people asking me the question about the attendance. So currently that we have 5 attendance. So if you're missing 1 attendance, you're gonna miss 20% of a grade, and it's really important that you let me know your name and so on and so forth. Okay. It's really important that we take attendance and go to the class because part of your grade. Um, so far that I believe that I grade most of you, except for the fact that there was some file that I cannot read. I will email that person, or maybe there was some internet issue that your grade wasn't up yet. And so the grades basically everything should be uploaded in Blackboard. You can check my grade and so on and so forth for that part. For some reason that again that there was some of you that I may not grade you because if you did not really write down the answers on it, so it took me slowly, took me a little bit time to get it graded. So let's say I have to look up the questions and then see if your answers actually match the answers that they have from the question. So if you write down the answers on the exam, so that will be a lot easier for me to grade. But you don't really have um, any issue with that. So I'm perfectly happy with the way that you rate. Again, that there's no bias when you grade the exam, regardless your format. If you write really well, but if you answers the wrong question, I still don't get point. So making sure that we take care of that. So let me just share the screen. Again, that we have 5 attendants, and this is what we have right there. And um, of course, I can let you know whom that person attended, but generally, this is what we have for the attendance. And um, for the homework problem, so I will try to finish grading it tonight, and hopefully I can get it done. So for the first 5 homework, and you should get the grade very soon. And there's no homework 6, so I apologize. There was a person who asked me, um, so she missed the class, or if I can get my homework 7 count twice. The answer yes, but there's no homework 6, so this is my apology. So making sure that we have no homework 6. So if you were told that I got my next homework counts twice, so that should be homework 7, or homework 8. If for some reason that you missed the class because I have to go to the whatever it is, okay. So that would be another reason why um, we we need to be mindful for what we have right there. So we have total 7 homework so far, and homework 7 I have seen people submitted, and there were 3 or 4 people submitting the homework 7. That would be great if you finish it. Just submit them. So homework 7, 8 will be due at the end of Monday. So that is a very good question to ask. So they will be due next Monday, 11:59 p.m. So on Tuesday morning, so I will close it. You will see that this will be disappear very soon. Very easy for me to make it unavailable. And I will post solutions for homeworks 7 and 8 so that we can study in advance. So remember that the final exam will be on Thursday, July 2nd, right? After that, we don't want to have the exam next Tuesday, July 7th, right? So after the exam, we should celebrate a little bit for July 4, whatever it is, right? So that's fair enough that we have the exam next Thursday. But for you guys, but for me, I have to grade it, of course, very, very soon. Probably you will see the grade a week after that, or maybe before that. No, you should not wait a Tuesday. Just um, just wait until I would say until this afternoon around 2 p.m. So after the class, I have to have lunch a little bit. I would check all the files that people submitted and regrade that a little bit. So um, yeah, so you should get the grade this afternoon and all your homework grade at the end of the day. So I wasn't really comfortable with my eyes because I have eyes irritation during the week. So that is my big concern, and so I couldn't really keep up the work. Um, yes, you still have to wait for the grade, but some of you actually got the grade, I believe. I There was some reason once I graded, and then I went to type in the grade, upload it on Blackboard, took a while because the system was slow. Yeah, so you should get the grade uploaded around 3 p.m. If you don't get that grade, just email me. I will let you know what it is for sure. Yeah, I believe I grade almost all of you, but except for a few. And of course, that I will basically finish it. The only reason that really take me that long to finish grading because sometimes it's about the internet connections and also the format, but it's not a big deal. But you should be able to get the grade very soon. So anyhow, we actually finished the first part of the final exam. So now we're gonna actually have to prove something. But the proof that we're doing today or for the rest of the class are not very challenging from my own opinion, but I'm not sure about you guys. Okay. But this is the very, very basic proof for us. Okay. If you want to study more advanced math, let's say you want to um, for example, that you want to um, prove it for the limit part. So let's say the limit when x approach infinity and y function, the function of x basically approach the limit 1/3, for example. So we have to write another way to prove that. So this is not easy as we have from the calculus 1 or calculus 2 that we only deal with the work, but we never actually seen any proof for the limit part. So we are being told, so when x approaches 3 on the right, so 3 plus, and then the function f of x basically approaching 0, for example. So this is what we are being told, but we are not really taught how to prove that. Of course, that if you really want to take it, so there is another course, so that should be 150 or something like that, or 160 something. So that would be another level of the proof. Of course, that we not really do so much on this class. So what we trying to do um, will be the following thing. Okay, so I believe that we have seen the lecture note 8, and this is important for us because this is the proof that we consistently use for the rest of the class. So again, that it might voice is broken, for example, that because of the connection, let me know so that I can reset the internet Wi-Fi for that issue. So I will guarantee you that it will never happen again. If I can talk to the people who are in charge of the internet service. So anyhow, this is what we have for the proof, and then the method that we'll be using would be 4 different methods. So the first method that we call direct proof. The second will be proved by contrapositive. The next that we prove by contradiction. And the last one, so that would be the proof by induction. So we are responsible for all of these 5 single proofs. Okay. And each of them, they have the similarity. They also have the opposite characteristic. Okay. So for example, direct proof. So what I mean by direct proof? The proof of the statement is generally means that we trying to prove it from P. It have to be the both statement to Q. Okay. Yeah. So this is what we call direct proof because we just prove directly from P to Q. So we are given by the conditional statement, which is P. And then we're trying to prove that, well, if P and then Q, so we just take the information from P and to prove the Q. This is what we call direct proof. All we need to do for that is just utilize the information from Q and prove it. Okay, so I put the equal sign, meaning that we want to interpret that in terms of word so that we can know what it is. So use the information of Q, of P, to prove Q. Yeah, this is what we call direct proof. So there's no argue about that. Well, direct proof meaning that P go to Q. That's it. You use information of P and then you prove Q. So this is very, very simple. And the next part of it is we call contrapositive. So what is contrapositive? So we do not, there were some situation that it's really hard to use the information of P and to prove the Q. Sometimes you have to do the opposite for that part. And this is what we call contrapositive. So you can see that the logic that we use for contrapositive will be not P, not Q. Okay. So you have to be the other way around, right? And imply not P. I believe I did the truth table for us, and they have to hold the same. Okay. So you can try them. So let's say P imply Q, and then so you can have like a true for false and true for false, whatever it is, and then go for P imply Q. And then we do the opposite for that. So not Q imply not P. So they must be the same, right? So P imply Q will be exactly the same as not P imply will be exactly the same, okay? Imply, I'm sorry, not Q imply not P. So it have to go with the not Q first and to prove for not P, okay? So, so this is what we call the contrapositive. It looks complicated, but it's actually pretty straightforward from what we have. And so what is the contrapositive proof? So we're going to use the information, use the negated information from Q. Remember, from Q, you have to start from the result statement. We cannot start with a conditional statement because the conditional statement is more complicated. Okay, so we start to the negate information from Q to disprove P. Okay, as simple as that. So disprove P meaning that we're trying to prove P is wrong, as simple as that, or false. It's the appropriate term for that. So what that means is that instead of I'm proving directly P imply Q, then we do the opposite. Not Q implying not P. So this is a very good example. So let's say we have um, um, there was a certain example that we going to write them down, right? So a very good example, meaning that differentiable, right, imply continuous. So this is true for all the time, right? And so how can I make the same statement for that part? I'm going to write them down as, so this will be the same as proving the same. Usually have a little bit right there. So they're equivalent. They're not the same thing, but you know, equivalent meaning that this is the resulting information that we have compared to the earlier statement that we're trying to prove. So they're equivalent to each other. So that would be the same as proving not continuous, uh, implying not differentiable. Okay, so this is basically the same thing as we took the resulting statement and disprove the conditional statement. So they basically mean the same. So it's really hard to understand it that way. So we can try, for example, and understand what that means. So we combining lecture 8 and 9 together. So today going to be a lot of work that we have. But we're not trying to go to the like intermediate value theorem or something really, really hard to prove. Okay, so we're trying to get to like a certain things and see what it is. Okay, so let's try a few examples and see what that means. So let's try like a 2 example. We're gonna go for the this. So again, I'm not gonna copy down the answers. I'm just I'm not gonna type them down. Just copy and paste. It's easy for me. Okay, so this is what we have for the question. So when we're gonna use direct proof, so the question state that we use direct proof to prove it. On a final exam, we're gonna do the same thing as well. Use direct proof and prove the statement for that. Okay. So if x is odd, then x squared is odd. This is the thing that we use direct proof. The p will be x is odd and x is odd. So we're going to put them down. X is odd. And the q that we have is x squared is also odd. So this is what we're trying to prove, right? So the thing that we're going to do will be p imply q. Okay. All right. So if x is odd, then x squared is odd. So if x is odd, what happens? So we can take when x is odd, meaning that we can rewrite x, right? We can rewrite x in terms of 2n plus 1. Okay, so what is the n? Where my n is belong to an integers, right? It doesn't necessarily have to be the positive. It doesn't necessarily have to be a negative. So it can be an integer z, right? An integer meaning that it can be either positive or negative. So x can be either a -3. So we put them down. We could take 2 times -3, which is -6 plus 1 is -5, right? So 5, -5 is an odd integer. So so we take that for an integer for that. So generally, the logic behind that for this type of question is that when x is odd, we should have like a 2 different statement. So x is odd. We're gonna take x basically equal to 2n plus 1
It doesn't necessarily have to be the n. You can have x equal to 2p plus 1. It doesn't matter to me. Where n is belong to z. Okay, so this is what we going to have, right? N is an element, right? So when n is an element, is any number for that part. So you're gonna use this guy. It's not a set. I'm making sure that we don't um, get confused with that. Okay. So similarly, when x is even, this is the most interesting type of question that you see on the exam. So meaning that we can tie x is equal to 2n when n is also in z. Okay. So that is a very important statement that we should utilize this information. So meaning that the z can be, the n can be any integers from positive to negative numbers. We can take n equal to negative 100 times 2, so that would negative 200. So x still be an even number. Okay, so when x is odd, then x squared is also odd. This is what we're trying to prove, right? So we can try them. So let's say we take negative 25, and then I square it. I have x squared equal to 625. And so that is an odd integers, but we can use any specific number, specific case to prove the statement. Remember, in order to prove a statement, we need to generalize the informations and prove it. So remember, we cannot use, this is very important. This is what we usually use. We cannot use any specific, okay? Any specific. We cannot use any specific example to prove any statement. All right, so this is wrong. Okay. However, to prove any true statement, but how can we prove? How can we disprove the statement for that? How can we prove the wrong statement? Another word for that. So, in fact, we can't. Yeah, this is very. We can, right? CAN. This is CANNOT. We can't. In fact, we can't use one counter example to disprove any false statement. Okay. So, for example, I want you to disprove a certain thing. This is a very, very interesting. Okay. So, for example, I'm going to give you one example for that. This is a very, very important information. So, let's say I'm going to give you the statement, if an integer is divisible by 3, then the integers is also divisible by 9, right? So this is literally not the true statement because I can find one counter example to disprove it, right? So the counter example that I'm going to take, I mean, there are roughly many counter example to disprove that statement. So we can take 12, we can take, 15, 21, whatever it is, right? So counter example is 12, right? So there's so many of them that we can use, but take one of this. We only need one counter example. There's no S for this. To disprove the one counter example, okay? If you can find more, that would be great, but we only need one counter example to disprove the statement. So we can have 12, 15, so on and so forth, right? So all of that integers are divisible by 3, but those are not divisible by 9. So we can't really, use that statement for that part, right? So this is true, okay? So this is the false statement. So we can prove that this is a false statement, okay, by taking a counter example for that. This is a very, very important strategy that when somebody gives you something, how can I disprove it? I mean, disproving any statement is a lot easier than proving the true statement, because when we try to prove the true statement, that we need to generalize the cases and prove it. Okay, so we cannot take any example to prove that. So this is a true statement for sure. So that's the reason why we cannot use any specific example, right? So just like I said earlier, can we use 25? Because 25 is an odd numbers. 25 is an odd number, so that let's say 25 squared that we have is 625. So 625 is actually um, an odd number, so we cannot take that. So this is very important strategy that we should employ for that example. So now I'm giving, so the statement gives us x is odd. So we're trying to prove that x squared is also odd. The way that we prove it, I feel like my internet is very unstable. Can everybody hear me? Okay. Okay. Let me try to prove it then. All right, so it doesn't seem to be working that way. Let me try to prove it. So, not sure if my connection is back. All right, so, so that thing that we have when x is odd, then x equals 2n plus 1, and then we're trying to prove x squared. So x squared that we have is what? So the x squared that we have would be equal to 2n plus 1 n squared, right? And this is all we need to do. Okay, so, and we try to prove this as an odd integer, so we're going to expand them, so that would be 2n plus 1 times 2n plus 1, and using the for method that we learned, so we can have to expand this, right? And so we're going to get 4x squared plus 2n plus 2n plus 1. Okay, so similarly that we're going to get like 4n squared plus 2n plus 2n plus 1. So in this case that we're going to get 4n squared plus 4n plus 1. So we almost finished that, except for a little minor thing that we need to do. So 4n squared, right? So how do we know this is a an odd integer? So we're going to rewrite this in terms of like we're gonna factor out 2. We'll factor out 2 for 4n squared plus 4n. You're gonna get 2n squared plus 2n and plus 1. Okay, so the whole point of doing this is literally we're trying to factor out the this guy, factor out this. Okay, we factored this out, and we're gonna have this as a 2 times 2n squared plus 2n. All right, and let me see, my connection is also stable. All right, so now we're gonna go to so this is I can denote, I can take this guy as I call it this as 2p, okay, plus 1, right? Where my p is 2n squared plus 2n, right? So apparently this is n. I'm sorry. Okay, I'm doing a little bit too fast for that. Right. So we can literally see that we write this x squared in terms of 2p plus 1, which is an odd integer according to the definition that we have right there. Okay, so this is basically an odd integers, and then we just prove it. That's it. Okay, as long as we can write them down, odd would be 2n plus 1, even though it would be 2n, or n can be any number It doesn't necessarily have to be an n. You can use p or z, whatever it is, okay? So let's a, b, c be in integers. If a divide b and b divide c, then a also divide c. So this is a very, very important statement that we should understand, right? So when a is a multiple b, so we can also, so a divide b, right? And meaning that, so we're gonna use direct proof. So we're trying to take this p informations, right? This is the p information, and then we're trying to prove q, right? So this is the q, correct? So all we need to do for that part, so we're gonna rewrite b in terms of and a, right? N times a, right? So a will be in integers, correct? So let's say we have 3 divide 6, because 6 equal to 2 times 3, right? 3 divided by 252, because 252 will be equal to 84 times 3, right? So this is any integers n, so where n will be an integers, right? Where n is an integers, okay? Basically belong to z. This is all we need to put them down. Okay, so similarly, so and meaning that we need to use the n part, the n information. So b divide c, right? And is really important. So we can use you have to use this information to prove q. Okay, so meaning that I can write c will be equal to n times p, where my sorry, not the n, I apologize for that. So it have to be different integers. It cannot be n, right? So we cannot use the same multiple of that. So we're gonna take m, okay? Or p or q, whatever you want, okay? Where my m is in z, also in z. All right, so this is a very, very important information. All right, so now after that, so I'm gonna rewrite c in terms of what? In terms of n times b, right? So this is what we have earlier, using the second Higgs of using the second information of p equal to, I'm gonna rewrite c in terms of n times b equal to m times n times a, right? Because we can utilize that information. So because b, this is the b equal to n times a, right? This is the b, correct? So we have the informations, and I'm going to rewrite c in terms of the m times n. I put them in parentheses because this is just a multiple of that. This is just an integers. I call m times n as p or q, doesn't matter. Right? So I call this as q. Okay, qa. Okay, so remember c is a multiple of a, so meaning that a divides c, as simple as that. All right. In other words, I'm going to write them down. So p will be equal to n times n. Just want to be more specific. What is the q number? So we need to indicate that. Well, all right. So c can be written down in terms of a multiple of a. So of course a divides c on that logic. It's very straightforward for what we have right there. All right. So for the next part of it, we're going to prove more and see the proposition is also really important. The basic trigonometry, this is really easy to prove. It's tan, cotan is pretty straightforward. We can do that. And so if n is z, so this one is even u cases. So there will be some situation where the question is getting really hard. Okay, so let's try C and D and how we can proceed that. Okay, so let's try this two example on the next page. I'm basically have a lot of favorite in trig. Yeah, I'm pretty good at trig, to be completely honest. So I love trigonometry a lot when I was young. So that is my favorite proof. I'm not sure what you guys and what it means by tan, cotan, secant, cosecant, and so on and so forth. Okay, so the function f of x is odd. There's no cases, so x can be any number, right? So this means that for all x, this means that for all x is in R. It doesn't really give it anything, so we assume that x is a real number, right? So the function f of x is odd. This is what we're trying to prove, right? So the way that we do to for the proof is very, very straightforward. So what is the odd function? What is the even function? So we're gonna need to have some revise. So let's say I might change to the even function for that. So if f of negative x equal to negative f of x, so meaning that f of x is odd functions, right? So this is the information that we should get it. If f of negative x equal to f of x, so meaning that f of x is an even function, right? And let me check my connection and see. Okay. Let's see it work. Okay, it worked. I'm afraid that my connection is not working. So we're trying to prove that f of x is an odd function. So we're gonna take f of negative x, right? So we're gonna take the negative x inside. We plug that in to the function. So the function that we have is x to the third minus 4x. So we're gonna take negative x, and then we raise to the third power minus 4 times negative x. So we just replace x by negative x and see whether or not it's give us this characteristics, which is negative f of x. So we good to go, right? And so the negative x to the third power, usually the odd power are going to give us the odd function, and even power are going to give us the even function. So we're going to get this guy is x to the third, negative x to the third, plus 4x, right? But we haven't done it yet. So we're going to rewrite this in terms of you put a negative sign out, and to see whether or not it's going to give us back the negative f of x functions. So what we have, this is x to the third minus 4x. Okay, so apparently that this is an f of x, right? We can literally check that, and so the entire thing going to give us this is a negative f of x for that part, meaning that f of x is an odd function, right? So f of x is an odd function, so it's different for that part. We finish. As long as we can have this characteristics f of negative x equal to negative f of x, so we can have f of x as an odd functions as simple as we have right there. So for the tan and cotan is similarly that we have a tan would be we're gonna prove it for this for all x, right? Tan plus this guy plus the cotan. So we're gonna rewrite them. So am I writing this down slowly through that. So we know the fact that secant is 1 over cosine, right? And we have cosecant, which is 1 over psi. So as long as can we write them in terms of 1 over psi times 1 over cosine, we good to go. All right. So so the tan that we have is, so the tan would be psi of x over cosine of x, and the cotan is basically the opposite, which is um, cosine of x over sine of x. So the whole point of doing that is we're going to use the cos multiply. So when we apply the cos multiply, we look for this part, and we're going to have to multiply them. So the cross multiply meaning that we're going to take psi times psi x, we're going to get psi square of x, right? And also the cosine of x times cosine of x, then we're going to get the cosine square of x. And we're going to combine it, the bottom part, which is cosine times psi of x. Right? So, but we also know the fact that by the unit circle, the psi square over cosine square, which is 1, right? And we're going to get the bottom, which is 1 over cosine times psi of x, and we're done. Okay, so it's very straightforward. And so 1 over cosine will be secant, and 1 over psi is cosecant. Okay, so this is all we need to do, and there's no other hidden proof for this part. It's very easy trigonometry. I believe that this is what we learned from pre-cal. I'm not sure if you learn it, but yeah. So those proofs are very straightforward. There's no trick behind that. There's no proof behind that. So we finish. All right. So let's try it out with another example and see how we're gonna get it done. So E is actually it's really hard for that part. Even functions, yeah, those are not too bad. But let's try it out with two of the example and see how we're gonna get it done. All right. So so this one is actually harder from the term that we have right there because of the fact that we have to use cases. So if n is in z, so it doesn't really give us any information for that, but I know that n would be in integers such that 3n squared plus n plus 14 will be even, right? So if n is an integer, meaning that n can be either even or odd, can be either or even or odd. Okay, so this is very important. So we're gonna get two cases. So first, we're gonna take n is even. So meaning that n will be equal to 2 m, right? Where my m is in z. Very, very important. I put them down, right? So now we're gonna rewrite this. We're gonna rewrite p as we're gonna rewrite q as the in terms of m and see whether or not it's gonna give us an even numbers. So in this case, so I'm gonna rewrite 3n squared will be 3 times 2m's, right? So n squared plug in m squared, n squared will be 2m squared plus n. So what is n? So n will be 2m. plus 14. All right. So in this case, that we can rewrite this in terms of, so 2m squared will be 4m squared times 3 will be 12m squared. M plus 2m plus 14. All right. So on that example that we can factor out 2 because we can do that. And we can have 6m squared. So we factor out 2. Yeah, of course we can factor out 2. 6m squared plus n plus m plus 14. So we call this guy as, I would say my favorite number is, I'm sorry, my favorite letters would be what? 2x, yes, 2x. We can call this guy x. All right, so that would be 2x. Right? So meaning that this guy will be an even. Okay, so this guy will be an even. Be good. Right? So 3m plus 2m plus 14 will be an even. Similarly, when n is odd, right? When n is odd, meaning that we can rewrite n in terms of 2k plus 1, where k is also in z. Remember, we cannot use the same m, or it should be different, okay? To be more general for that questions, so we need to make sure that the value should be different. Okay, so now we're going to rewrite 3 n squared in terms of 3 times 2k plus 1 squared plus 2 times 2k plus 1, right? Plus n, which is 2k plus 1, and plus 14. So we're going to expand this a little bit. And again, the expansion should be in terms of 2k plus 1 times 2k plus 1. All right, so this is the thing that we need to put them down. And multiply by 3. So I'm doing a little bit fast, so we can just apply the form method for that. And so that 4k squared plus 4k plus 1. And it turns out to be the 12k squared. So I'm doing a little bit fast for that part. Plus 12k. Okay. Plus 1 times 3, which is 3. Okay, so we expand this in terms of that one. We can't do it by itself, so that would be 2k plus 1 plus 14. So we can check them. So this one will be, we're going to simplify it a little bit. So that would be 12k squared plus, so this is 12k plus 2k will be 14k plus, so 3 plus 1 is 4. So 4 plus 14 is 18, right? And we can factor out 2 in this case, so such that we can have the entire set done in terms of 2 times 6k squared plus 7k, so we factor out 2, plus 9, okay? So I call it this as you know, q. So we're gonna get 2 times q will be an even, right? So this guy also in even numbers, right? Even. We're done. Okay. So similarly for that, for using direct proof when x is an even integers, then x squared minus 6x plus 5. So when x is even, so we can rewrite x in terms of 2 times integers, right? So x is even, then x equal to 2 times s, for example, 2s, where my s is in z, right? So for this part, so that we can rewrite x squared minus 6x plus 5 in terms of s. So we can have 2s squared, right? So x squared would be 2s squared, x is even, minus 6 times 2s and plus 5. Okay, so this will be an s. This is not number 5, just for clarification. Okay, so now we're going to get this guy. 2 times s will be 4s squared minus 12s plus 5. So I need to make sure that this is an odd integer, so I'm going to break it down, this guy, in terms of 4 plus 1. And why I have to break it down in terms of 4 plus 1, because I'm going to factor out 2 for all the cases plus 1 at the end. So we're going to get this guy will be 2 times 2s squared minus 6s plus 2, right? So remember, I split 5 in terms of 4 plus 1, so we're going to have 2 on the remainder. We're going to have plus 1 at the end, right? When you factor out 2, and this is what we have to look at. And we can call this guy as 2 times p, and make sure I put him down on the exam, 2 times p and plus 1, right? So this will be an odd. All right, so we finished that part of the question, and apparently that we this is the thing that we spend time working on it. And similarly, this even function is easy as just plug in negative x, so you're going to get back to the original function. So that's pretty much a thing that we need to do. Okay, so we're going to take a look at the last one is D. These pretty interesting questions that we want to look at. C was pretty easy, but let's take a look at the D questions and see how it's going to help us, that part. So we know the fact that if 2 integers have opposite parity, then their product is even. Of course, they have same parity, then no, we can't say that. So they have the opposite parity. So that assuming 2 integers x and y, right? In Z. So they have the opposite parity. So opposite parity meaning what? We have opposite parity. So have opposite parity, right? Meaning that either x is even and y is odd, or x is odd and y is even. Okay, so we're not going to do like both of them because they're basically the same thing, except for the fact that we don't know what the x and y are. So either one of them is odd, one of them is even, as simple as that. So without loss of generosity, without loss of generality, this is what we're going to be doing. We assume that x is even and y is odd. Or you can do the opposite, it doesn't matter. So when x is even, that we can have x in terms of 2n plus 1, right? And y will be 2k. And of course, the product, so we're going to take the product for that, x times y times y. So when we multiply them, so we're going to get 2k times 2n plus 1, right? Do you believe that this is an even? Of course, when we take an even number, we multiply by an odd numbers. So, or any number for that is have to be even, because this guy, I can call it this as 2 times m, right? Where my m is basically k times 2m plus 1. Okay, so we finish. So this has to be an even, right? So this isn't even. The product is even. So as simple as that, and there's nothing else that we can do, but you don't have to do x equal to 2 q and then y equal to 2p and plus 1 and then do it again, right? X and y can be either odd or even, but they have to be one odd, one even for that part. So it doesn't matter that we're going to just take it one case where x is odd and y is even. I can do the opposite for that, it doesn't matter. So now we're going to go to the next part of the question. So I believe I finished this part, and we're going to close all of that. And we're going to go to, I believe that we posted for week 5, and we're going to have lecture 9, 10, and 11 for that part. So it might be like a little bit harder for us to do so. So let's go for 9 and see how it goes. So this is what we have for the contrapositive proof. And remember, the contrapositive proof is the proof that we cannot use directly to prove P implied Q. We have to do the opposite for that, not Q implying not P. So we have to be the statement that we have right there. So let me just repeat that again for the contrapositive proof. So instead of for P implied Q, so we're gonna take, you need to prove not Q imply not P. Okay, so this is very important that we do so. Not Q imply not P. So we have to do the result statement to prove to disprove the conditional statement for that part. So so the contrapositive of the true statement, if S is squared and S is a rectangle, so that will be the statement. If S is not a rectangle, then S is a square. So they are equivalent to each other. So we don't really have to deal with that. So similarly for that, so if a function is differentiable at x equal to x, then it is continuous as actually obviously, but we can do that with the with the contrapositive proof. For that would be the same thing. If a function is not continuous, so we need to negate that Q statement and disprove the P statement. So then it is not differentiable as x equal to 8. Those are logically equivalent. So this is what we need to be doing for that part. Okay. But we cannot do the opposite for that, right? So we cannot do like not P. So this will not be the same as not P imply not Q. Remember, P imply Q will not be the same. So this is not the same thing as not P imply not Q, right? So this is the wrong statement. Yeah, we cannot do that. In fact, it will be the same as P imply Q will be the same as will be logically equivalent. So not a same thing. I would say there's nothing such a same thing. So they're logically equivalent for this part. Would be not Q, imply not P. As simple as that. So we're going to take the result statement to disprove the conditional statement. So this is all we need to do. Okay. So the thing that we're going to have for a certain example, let's say we have 2 example, and after this 2 example, I will take the attendance for that part. Okay. So I'm gonna just copy and paste for simplicity. So we're gonna take that, show the following contrapositive proof and why you should get stuck in direct proof for that part. Well, I mean, it's not stuck, it sometimes just take longer to finish. Okay, so this is an example for that part. So it's really hard to take, like, if how can you do direct proof for this, right? So if 9x plus 9 is even, so let's say we use direct proof and see. I mean it's possible, but it's just longer direct proof. For this part. So let's say 7x plus 9 is even, right? So meaning that I can rewrite 7x plus 9 will be 2m, right? And then I solve for x. So I'm going to get x will be equal to 2m minus 9 over 7. How do we know that this, so this will be an odd numbers. How do we know that this is an odd number? I don't know, right? So there's no such a case that implying that, well, this will be an odd. So we're going to get stuck right there. There's no way that we can prove it. I mean, we can, but it'll take longer to get it done, right? And so, yeah. So this it just take longer to prove the statement to use direct proof, and it got stuck right there. How do we know? How do we know that? How do we know that x is odd? Okay, so it's harder to do so, right? So, but we can try some example. Let's say we took x equal to 1, so 7 plus 9, 16. That's that is even. So x equal to 2 doesn't work, right? X equal to 3, 21 plus 9 is 30, so that would be an even. 4 doesn't work, right? So on and so forth. So we can't not deal with that. But we can try to resolve. There will be some situations that we can try to resolve the x in terms of, we can write down the x, which is in terms of like a, so we have to be a multiple of 7, right? And so this will be an integer, so we can call x will be an integer, so we can be like the z for that part, and then we solve for n, we plug back in, we solve for x again in terms of z instead of in terms of that. I mean, we can get it done, but it's just take longer to get it to do so, and it's not worth it for that part. Okay, so we try to disprove this is we try to prove that x is odd, so this way is actually not really effective. Okay, so this is what we call the p, and this is the q. So we're trying to prove this, right? So in other words, what we need to be doing on that example, we're trying to use the fact that x is odd, but instead of that, we can prove not q. So not q meaning that we can use contrapositive in this case. Not q for this part, which is x is not odd, right? right? So not q, meaning x is not odd, meaning that x is even, right? So x is even, I can use x is even such that basically mean x equal to 2m, where my uh, m is in z, right? So I feel like that's going to be a lot easier. All we need to do are trying to disprove that 7 plus 9 is not even when x is even. So this is all we need to do. So for that part, we're going to we're going to plug in x equal to 2m into 7x plus 9. So we have 7x plus 9, which is basically equal to what? So x is equal to 2m, so we're going to take 7 times 2m plus 9, and we can have this is equal to 14 plus 14m plus 9. And of course, some of you might be saying that, well, this is odd, but we need to factor out. We can rewrite this as equal to 14m plus 8 plus 1. Why do we have to do that? Because I need to rewrite this in terms of 2 times something plus 1. And when I factor 2 out, I'm going to have this is 7m plus 4 plus 1. Okay, so I call it this is 2L plus 1, right? So this has to be an odd, right? So we done, which is odd, right? We're trying to disprove that 7x plus 9 is even, meaning that we're trying to prove that 7 plus 9 is odd given by x is even. So this is all we need to do for that part, where my L equal to, no, I'm not, I can't do that. Where my L is equal to 7m plus 4. Okay, so using the contrapositive proof in this case is actually a lot easier than using the direct proof on that example, because we can see that the conditional statement is more complicated than the resulting statement. So it's always better that we take the contrapositive proof to show that the result statement is false in this case. So similarly, we can do question number 2. We're going to do it real quick for that. And after that, we're going to call it a day. And if you have any questions regarding the homework, also let me know. The exams, also let me know if you have any question for that. Okay, so apparently we can see that this is P imply Q, right? So we see that Q is really complicated. So we can use not Q imply not P. So they basically the same thing, right? So in other words, we're going to take X is odd, so we're going to take X is not odd, meaning that X is even, and or X equal to 2 times M, right? We can use any a 2K if you want favorite, where my K is basically K is in Z. All right. So after that, we're gonna rewrite x squared minus 6x plus 5 plus 5 in terms of the k. So we're gonna plug in x equal to 2k into x squared minus 6x plus 5. So we can have 2k squared minus 6k, 6 times 2k, and plus 5 in this case, right? All right, so now we're gonna have the statement such that we have 4k squared minus 12k and plus 5. Plus 4 plus 1. So we're going to rewrite this in terms of an odd. So we can disprove the statement. We're trying to prove that x squared minus 6x plus 5 is odd, given that x is even. So we're going to factor 2 out, and we can have 2k squared minus 6k plus 2 plus 1. Right? And we can call this guy as p. And we have this as 2p plus 1. Okay, so the fact is, this is basically the thing that we have where my p is, we need to rewrite them where p equal to, you need to tell me what it is. You can't just put them down. 2k squared minus 6k plus 2. We've finished, right? And this is not. We finished for that part. We're trying to use the not q to disprove not p done. So we can basically see that p is a very, very complicated, and we always we try to use the contrapositive proof for that part, right? So contrapositive proof. So we're gonna work through that again on next Tuesday with a contradiction. So that'll be on June 23rd, and then we wrap all the lectures on June 25th, and then after that we're gonna have the final exam review on June 30 with solution posted after that day, and after that we're gonna have the final exam on July 2nd. Okay, so anyhow, this is all we need to do for that part. Oops. And there's nothing else that we can do. So anyhow, we finished the part, and now we're gonna take attendance for this part. There was a file for this, and again, when you want to go back to the lecture notes, and this is all we need to have for the note that we took on a day that we have right there. So now we're gonna take the attendance and see if we can wrap them up early, and so that'll be easy. I think did I post the recording from last class on YouTube? Not sure. I think I did, right? Did I? Yeah, I would do it. I think I would do it every day. So now we're gonna take attendance for that part. Daniel, yeah, I think we put them in order for Valentina. I'm not sure what the iPad to everyone, so we need to tell me your names. Gyro's here, yes, and Richard's here, and C's, I saw her. Aris is here, fantastic. Paulina is here, fantastic. Brander, fantastic. Mark is here, Lawrence is here, Hannah just saw her names. Kenneth Milano is also here. WT, I don't know what that person is. Please tell me your name, so that'd be great. Haditz is here. Jakir, Mackenzie. Okay, so Milano is here. Jakir is here. And Copy is here. Fantastic. Kim. Kim Mentis, fantastic. Winnie's also here, yeah. And Yvonne's is here. Yvonne's here. You skipped Mark Hansen, I apologize, Mark, for that. Fantastic. Art is also here. Yeah, remember, attendance is going to be 20% of your grade. Please try Linda is here. And I'm going to fix my connections and continue on the work that I left over. And you guys should be able to see all the gray very smoothly around 3 p.m. today. Usually sooner than that. Should be 2 p.m. So around that time. And unless that you missing some documentations or maybe you uploaded a file that I can read, so it might take a little bit longer for that part. So if you want the grade comes out smoothly, it's always good that you uploaded something in terms of Word or PDF file. So Patricia, so here, Daniel's, I think Daniel's here, right? Daniel's here. Let me just check the message for that part. Oh yeah, so I saw him type in. Okay. Yeah. Yes, homework A will be due on Monday. I would say. Well, I am very lenient for the homework. Usually, I let it due at the end of the semester, but I don't want you guys to scream for the homework problem and then have all the solution posted. I really studied too much for that, right? Ariel was here. Mohammed is here. John is here. Yeah, I heard you. Present. Mimi is here. Okay, saw her. And Lawrence on fantastic. Array. Did I meet someone? Ariel's here. Ariel. I think. Yeah, I think I saw her. I saw him. Her. And I saw her. Him. That right. Oh, no, I don't see his name here. Ariel. So did I meet someone in this class? There was a person who was absent. Okay. So again, that the attendance based upon the 5. So now we go to the 6th one, and very likely we're gonna have. I'm gonna give you guys one bonus attendance. That will be so 6, 7, 8, 9. So we had 10 attendance in total. So if you miss any of them, you're gonna lose 10%. With 2% of the grade. And please try to be present to this class. But that's the way it is. So again, I'm going to post the homework problem very likely to be at the end of the day. If not, I am going to post the grade over the weekend. But the midterm should be done by 3 p.m. today at 2 p.m. So, okay. So if you have any questions, let me know. If you have anything I cannot read, I will email you. Okay. So if I cannot read your file, I will email you for that part and have you resend them and making sure that you not let it happen on the final exam. So anyhow, you guys going to have a great day, and I'll see you again next Tuesday. Take care.